In this question, positive charge Q is distributed uniformly over a circular ring of radius capital R. A particle having a mass small m and a negative charge small q is placed on its axis at a distance x from the center. Find the force on the particle and assume that x is very less with respect to capital R, and then find the time period of oscillation of the particle if it is released from there. So let's draw the figure. As you see in this figure, we have a circular ring where the charge is uniformly distributed over it, and the total magnitude of the charge is plus capital Q, and this is the radius of the ring. So at the center, a point P is present at the distance of x, and the mass is a small m and the charge is minus q. So we have to find how much force is acting on this point P. So first we make a very small component of a charge. We can name it as dq. And then we join this dq with the point P. So this is the df, force acting on it. Here is the theta. So if we make a component, this is f cos theta. So this is a one point. Suppose if we take one more section, suppose this is again dq, and if we join it, so here this is also df. So if you again make the component, this is theta, this is also theta, so this is df cos theta. But what about the sine theta? Sine theta will be df sine theta upward direction, and for the down one, this one, it is df sine theta downward direction. So both will cancel out. Means all the force is acting on the x-axis, which is df cos theta. So I just explain you for your understanding. We will only consider one section. So now total force is equal to the integration of df cos theta, and we have to integrate it, so we will get the net force acting at point P. Now based on Coulomb's law, we know that F is equal to 1 by 4 pi epsilon naught negative q into dq divided by r square. R square is here. Suppose this is a point A, so the distance of AP. So AP square. If we substitute the value, df is equal to 1 by 4 pi epsilon naught minus q into dq by root of r square plus x square whole square. So from here we got the value of df. Now as you see the figure, OAP cos theta is equal to x by root of r square plus x square. So from here we can write it as f is equal to integration of 1 by 4 pi epsilon naught minus small q into d capital Q divided by r square plus x square into cos theta is x by root of r square plus x square. If we solve it further, f is equal to 1 by 4 pi epsilon naught r square plus x square 3 by 2 into minus q and the integration of d capital Q. So the integration of the dq will be equal to the total charge acting on the circular ring. So F is equal to minus capital Q small q by 4 pi epsilon naught r square plus x square 3 by 2. Here x is also present. So according to the question, x is very less than r. So from here we can write it as f is equal to minus small q capital Q x divided by 4 pi epsilon naught r to the power 3 1 plus x square by r square 3 by 2. So here x square by r square is approximately 0 based on this condition. So from here we get the force value. It's equal to minus small q capital Q x by 4 pi epsilon naught r cube. So this is the force acting on the point P. Now we have to find the time period. So in this case, T is equal to 2 pi root m by k. We know that F is equal to minus k into x. So from here, k is equal to a small q, capital Q by 4 pi epsilon naught r cube. So substitute the k value in the time period formula. T is equal to 2 pi root m by small q, capital Q by 4 pi epsilon naught r cube. So if you solve it, T is equal to 2 pi root 4 pi epsilon naught m r cube by a small q into capital Q. If we keep this 2 pi inside the root, so it will come as 16 pi to the power 3 epsilon naught m r cube by a small q capital Q. So these are the answers of this question.